Well, hang in there, guys. We're halfway through the last session of the day. Thank you for sticking with us, and there's some great speakers coming after me, so don't rush away yet. Okay, I'm going to talk about trying to improve some state fire mapping and monitoring. Can I just have a show of hands of anybody who's heard of TERN AusCover data? Excellent. I don't have to sell it then. Okay, for the few of you in the room who aren't aware what TERN AusCover is, TERN stands for Terrestrial Ecosystem Research Network, and that was set up about 9 or 10 years ago, and was one of the first initiatives under the NCRIS. And the main objective is to create and collect ecosystem data for research and management. And the really good thing about it is that it's free, very easy to download with no restrictions. There's sort of 3 different levels. There's sort of super sites where there's really detailed information about all sorts of environmental factors. There's a sort of regional level. And the one that I'm most interested in is the AusCover. So this is at the landscape level. And it uses predominantly remote sensing data products. So satellite imagery, aerial photography, and other remote sensing. So there's lots of different satellites up in the sky there, all with different resolutions. Lots of different products have been developed from each of these different satellites. Over the years, Doudna have been mapping fire in the state. They have predominantly concentrated on the agricultural regions in the south, and occasionally they've mapped fires in the more arid and semi-arid regions, but particularly when they know there have been big fires. So this data set isn't complete. So it's sort of the best attempt that they've done over the years, and different methods have been used for different years, either using satellite imagery, some GPS, some mud maps. So there's a whole collection of different technologies and approaches to it. Now, some of these fires in the north of the state are, probably the majority of them are from lightning strikes, and some will be anthropogenic burning, particularly up here in the AYP lands. So Doudna were looking for a method of automating mapping fires in these regions in particular, because as you can imagine, it's very difficult to get up there and map them on the ground. From the map here, you'll see that 2011 in the blue and 2012 in the red were really high fire years. And if you cast your mind back, it was sort of the end of the millennium drought, and sort of 2010 and 11 there was a huge amount of rain in that area. And that's one of the limiting factors in this region is continuous vegetation. So if there is a lightning strike, normally the vegetation is so sparse that it doesn't carry very far. But following big rains, you get ephemeral grasses growing up, and you've got this chance for the fire to spread for, tens of thousands of square kilometres potentially. So Doudna were looking for a method to automate the process of mapping, and they wanted to see the potential of some of the TERN data that in the AusCover data set itself, there's 8 different themes, and there's over 100 different data sets waiting there for people to use. So at Adelaide Uni, we had a look at it, myself and Ken Clark, and we decided to use 2 particular AusCover products. The first one was the seasonal fractional cover, and this is a Landsat product. So it's at a 30 by 30 metre resolution. It uses a JRSRP algorithm, and it has coverage for all of Australia. Essentially what it does, for each pixel, for each 30 by 30 metre pixel, it gives you a percentage of that pixel that's likely to be bare soil, or green vegetation, or non-green vegetation. So you can see, when you combine those 3 colours together, the red is the sort of bare soil up in the arid regions, and then we've got this greener vegetation in the southeast. So what we did was use the bare soil fraction, so just that one band that tells you how much bare soil there is. Looking at this one here, we can see in 2010 that there was a decrease in bare soil. So after the rain, there was an increase in vegetation. And in 2011, there was a decrease in these particularly red areas. So we're looking at the trend over 5 seasons from summer to summer. We then set some thresholds based on Doudna's mapping that they had done already. And we were able to map those areas where there was a large increase in bare soil fraction over that 5 seasons and classify them as a probable burn, and areas with a lesser increase as a possible burn. And if you look at the red areas here, the probable burns, this is for 2011, and compare them with Doudna's mapping, 2011 is the blue area here. So you can see there's quite a good correspondence. The difference being that the Doudna mapping tends to just map around the edge of the fires, where this is at a pixel basis, so it's a 30 by 30 meter resolution. We then use the Modus Fire product, which is at a very high resolution, so it's a very coarse resolution, 250 by 250 meter resolution. Doudna thought that was a bit too coarse for their mapping that they wanted, but we were able to use that, and where that matched up with the mapping that we did with the bare soil fraction, we could allocate the date to the fires, and that's an example of how we did the 2012 fires. And again, this is the different dates for different months, different colours for different months, and it corresponds very nicely to Doudna's mapping in 2012 in the red. So in conclusion, this is a new automated process of fire mapping using free AusCover data. And it combines the finer spatial resolution of the 30-meter resolution with the finer temporal resolution of the Modus data. I forgot to say the Modus data is daily data. And it's a new methodology that will provide Doudna with more, hopefully, reliable, consistent, timely, comprehensive and cost-effective fire mapping and monitoring. And it's helping Australia move towards a national methodology of mapping fire. So everybody's trying to use this sort of raster methodology now. Thank you for listening.